All right, so here we are, activity 1 in our Changing Life chapter, the fossil record and your community. So today we're going to really just talk about fossils. So make sure you write down notes on all the different kinds of fossils, how they're made, and I'm going to show you a quick video on how they excavate fossils. Okay, which you're not going to be excavating, but you're going to be looking at a lot of these kinds of fossils during this unit. Okay? Fossils are, let's define fossils, the preserved remains or evidence of a living organism, plant, or animal. I'm going to go pretty quickly through this because I want to get it under 10 minutes and it's going to be hard. All right, so you're going to want to pause and write this definition down. Okay? This is sort of the time period we're working in all of these when we talk about these different kinds of fossils. We'll show you fossils from this time period, just the Tertiary, which is the most recent, and all the way down to the Cambrian. Okay? Let's list the types of fossils. All right, you're going to want to pause and write these down because we're going to talk about each of them in turn. Petrification, molds and casts, imprints, freezing, amber, tar pits, and trace fossils. And they all tell us something a little bit different about what we're studying. Okay? So what is petrification? It's where rocks and minerals replace plant or animal material. Right? So let's take a look at what that means. All right? For example, trees and or bones. And the most common one, trees. Take a look. This is a petrified tree stump. The picture's kind of pixelated, but basically it looks like a tree, but that's solid rock. You can find these in the petrified forest in Arizona. It's kind of hard to see, but these are also petrified tree trunks, and they've been replaced here by different kinds of minerals, and these are solid rock now. They used to be wood. Okay, here's bird bone that's been changed to rock. You'll be actually seeing some fish fossils like this, and you'll be making puzzles, putting together puzzles of them. Right? This is a little baby bird fossilized in a rock. All right, and this is actually an ammonite shell that's been changed to rock. It's one of the oldest kinds of fossils that we can find, but the entire shell has gone from being a calcium carbonate mineral to just solid rock. And another chambered nautilus replaced by rock. All right, this is another really, really ancient organism. And finally, the same kind of chambered nautilus, if you cut it in half, you can see that it's also replaced by mineral. All right, so like right in here, we've got minerals in here, but then right here, it's rock. All right, just depends on what happens to it after it falls into the sediment and what kind of processes occur. All right, casts are molds that have been filled in with another material. Okay, and this is weird, it went backwards. So we're talking now about molds and casts. Molds are empty spaces left after the organic material decays, and casts are molds that have been filled in with another material. All right, so a mold is an empty space, a cast is something that fills it in, maybe sort of like a mud flow came in and solidified in there, and it made an actual casting of the fossil. So, for example, the eruption of Mount Vesuvius created both of these kinds. These are molds made from human bodies that were covered in ash after the eruption. So the human bodies were covered in ash, the organic matter decayed, but if you were to poke a hole in there, you would it would be an empty mold. And there's all different sorts of people that they found as they excavated Pompeii. It was amazing. But those were real people, and the organic material in their bodies has decayed and left that mold. Okay, imprints. No organic materials left, but there is an impression of the material. Okay, so it's kind of like when you put your handprint in the clay, and your parents then fire it, and you have a permanent imprint of your hand from when you were little. All right, I don't know if some of you have that, but or your footprint. They do it with your footprint too. Okay, so it happens naturally with leaves and other materials. All right, so here is a dragonfly imprint. There's no organic material left over from the dragonfly, but it's the imprint of its body, and now the organic material is left, but you still see the really cool dragonfly A leaf imprint. When we were doing paleo climates, we were studying all these leaf imprints that were made during those two time periods to learn about the climate, the change in temperature. And there's a fish imprint. You're going to be working. I don't know that we're doing a fish imprint as much as we're doing a fossilized fish, but we'll have a footprint like this. Okay. Fossils also get frozen, and sometimes the entire organism is frozen, and all the parts are left, including the soft parts. This happens a lot. This happened a lot in the last ice age, just 10,000 years ago. So they're not as old as the fossils you would typically think of. But woolly mammoths, saber-toothed tigers. This is actually a 42,000-year-old baby mammoth found in Siberia in 2007 by what would you call him? Like a rancher who had reindeer and was, traveling through. And I guess it had thawed enough that they could see the baby mammoth. All right, so let's move along. Whoops, we seem to be stuck. Let me go back. All right, I think that's all we have for frozen. Amber. Amber, a lot of people use as a stone, a gemstone, and they put it in their jewelry, and some people name their daughters Amber. But amber is actually tree sap that hardens over time into a clear gold substance. Usually we find insects in amber because it's actually, as the tree sap comes out of the tree, what it does is it covers up any sort of insect that may be in its path, and then that tree sap hardens until it's rock-like. Okay, and you never get like a woolly mammoth in amber. Okay, and this is actually an ant preserved in amber, and it's found in certain parts of the world where they had the kinds of pine trees that created this resinous sap. Okay. All right, and this is where we're going to watch a video. We're going to talk about tar pits. Tar is a very thick substance that's difficult to get out of. So what would happen is this really thick sort of petroleum goo would ooze up from deposits and would make a pit, and there would be water on top of it, and so animals would go and to drink the water, and then they would fall into the pit and couldn't get out. They'd sink in, and then predators would come to get them, and they would sink in. So the tar pits are just full of fossils, and the La Brea tar pits are in downtown Los Angeles. It's really cool. So it's usually those animals that lived in the last 100,000 years. Okay, so this is kind of the gooey, ooey stuff. This is what it looks like that they fell into. And animals get fossilized. I mean, you have a ton of different, you can see a jawbone here, like the bottom of the skull. You can see a hip bone here. You can see a femur bone here. I mean, they just get all in there and jumbled up, all right? So it's pretty darn cool. And this is the excavation process. And we're going to go to La Brea Tar Pit website, and we're going to play a 3.5-minute video.
Hi, welcome to Excavation 101. Today I'm going to show you just exactly how we excavate here at the La Brea Tar Pits. And right now I'm sitting in front of a deposit that's typical of what we find here. It's a jumble of bones from many different individuals. So right here we have a saber-toothed cat pelvis, a bison sacrum, and even the femur of a juvenile mastodon. And these guys are mixed in with thousands of other bones, plants, insect shells. It's really cool to see so many bones just concentrated in a small area. Before we start digging, we lay a grid system out over the deposit. Each grid is 1 meter by meter, and that grid will have a depth of 25 centimeters. That depth comes from the datum line that we set at the surface of the deposit. We choose tools depending on the hardness of the matrix and the presence of fossils. For an area of matrix surrounding bones, I would take a dental pick and carefully pick away at the dirt. For an area that's a lot harder and we don't think there's bones there, I would use a hammer and a chisel or a screwdriver. And that's basically our set of tools that we use every day. Right now I'm working with a dental pick around the saber-toothed cat ulna, and I'm removing the dirt that surrounds the bone. We call it matrix. And once I've gotten a little pile of that matrix, I'll put it in a bucket that's specific to this grade, and later they're going to clean that and sort that for microfossils in the lab. Before we remove a fossil from the deposit, we'll measure out its location within its grid. Depending on the size of the bone, we'll pick 1, 2, or 3 reference points, and each of those points will get a north measurement, a west measurement, and a depth measurement. After we take those measurements, we write them down in our notebook, and that's copied onto a card, and that measurement stays with the bone. Each of our fossil measurements is recorded in our field notebooks. The information in the notebook also goes on a card that goes with the fossil to the lab. Also in our notebooks we write down daily observations, such as what grid we're working in, who we're working with, the type of matrix that we're finding. Along with recording that data, we photograph and map every grid, and oftentimes we will take pictures of specimens of interest or geologic features.
All right, guys, I'm having a bunch of trouble with this, but hopefully you got all these 6 things down as to how we excavate. And this is an excavated mammoth fossil from the La Brea tar pits. And finally, we're going to talk about trace fossils. These show some type of animal activity such as burrows or tracks, worm burrows, dinosaur tracks. So these are worm burrows, huge old trace fossils. Right? There's no animal in there, there's no body, it's just sort of a burrow that's left behind so we can learn about how they lived. This is a trackway showing how an arthropod sort of dragged its body along the ground and through the wet mud. And finally, this is what you would find if you went to Dinosaur Ridge, and you can do that to get extra credit. They have 2 types of tracks there. Right here they have an iguanodon-like track, and here they have a theropod-like track. The smaller one, the bigger ones are iguanodons. Okay, and finally, 2 definitions you need to write down. Body fossils, such as bones, shells, leaves, petrified wood, show us what an animal or a plant looked like. Trace fossils, such as footprints or coprolites, show us how and where animals live. And you'll learn about coprolites in our lab. Okay, so that is the end. Let's see if it worked. See you in class.